Welcome to a new test and teardown video. This time it's a Siemens. I think they're actually called Siemens and Halske. The two German guys that made this radio receiver. So this one is a conversion receiver. So that means there is an oscillator and a mixer, and then we'll have some filters inside this receiver. The very, very special about this receiver here is the frequency range. And you're not going to believe this, but look at that. That is 30 hertz, and then all the way to 1 megahertz. I think this is AM only, and you can plug in headphones or an instrument, and then you of course select between the different ranges. We got 7 different ranges selected here, and then of course the ranges, they go here to the readout. I think there's a little bit of a mechanical problem because this is the 1-to-1, and then there's another super fine here, but then there's just also, oh, now it's working. How cool is that? Before I was doing this, I didn't get any response. So is it okay? That is why. Okay, I am such a muppet. So that is obvious what happens. So then this is off, then you do this, and when it's, aha, now it's coupled to the gearbox. Oh yeah, okay, great. And then of course we have a meter that will tell us something about the input level, and we got 2 different inputs, a balanced and a symmetric input, and that is of course the input attenuator and the second stage amplifier. You can of course adjust the different amplification, and here you select between headphones or instrument output here, right? And that's the on-off switch. This thing is, as you can see here, very, very big, and the weight is 23.5 kilos. It's in a nice wooden box. I don't have the front cover, and it should be locked with these. But since this was thrown in the dumpster some time ago, I really feel I need to open it first and do a deeper inspection before we can power it up. So I'm starting to work a little bit with the internal parts. Look at that attenuator here, how big and nice that is. Quite a lot of sections in here. We can't really go in there and have a look. But I realized the shaft was bent, and how is that possible to bend this one and not cause any kind of damage to those really, really nice knobs? I don't know if you can see this, how nice and smooth the feeling is, but this is just absolutely amazing to touch these. Ha! I love it totally. And yeah, I think I fixed this more or less. See? Now I can rotate it. It's still a little bit bendy. I have to put in the screw, and then it's probably gonna be, oops, it was like that, yeah? Then it's gonna be all right. So the internal parts, the case was full of some really nasty white powder, and I think I know where that is from. Look at that nasty potentiometer here. See? Look at that. So the metal here is like some sort of a zinc or tin alloy, and it's just completely corroded and real nasty. I'll have to take a little brush and just remove what I can see from the outside, but you bet it's full of this on the inside as well. The other switches, like this one for example, this is bandwidth and headphones and such. Look at the quality. I don't know if you can see this, but those little moving parts, they're hinged on this little black rotating part. So that means you can probably imagine that they are moving a little bit as well. So they create a super good contact, amazingly good contact, and there's a super good feeling. So if everything else turns out to be trash, then definitely these switches will be scored for some fantastic steampunk projects or whatever. Just the knobs would make somebody happy. Oh, they are nice. I love the feeling so much. And here is the frequency range switch. And you can imagine this one is connected to all those capacitors and resistors and such. And this is in a feedback loop with one of the tubes, and I think it is that one up here. And that is creating an oscillator. And again, it's the same super nice switches. I really love those. And maybe you can see that the entire cabinet here is full of some white powder and some nastiness. And that is because this one here is also made from the same nasty material that is corroded in a really bad white powder way. So this I have to see if I can get rid of before we can continue our little power up project. We got some really nice variable power resistors. Look at that little gearbox. Cute. And that's of course mains voltage input selection. A big hefty transformer. I believe we got a few relays for switching different things like bandwidth and such in this unit. So here's a real big one with 3 sections, but look at that one. I think that's another relay as well. In a really cute kind of style. Everything in here, by the way, is amazingly beautifully made. The way all the components are hanging and mounted, the way wires are bent and soldered. Just enjoy the view here. See the wires and the little bends and cute details all over the place. Here at the rear, you see the 3 tubes. And no, you see 4 tubes, of course. This one is the front amplifier. The first amplifier is, of course, the most critical. And see, it is mounted in a little rubber vibration isolation method here. And together with the input attenuation and attenuator here, this is, of course, the first stage amplifier, and that is most critical. The other 2 stages here, they don't really have the same kind of sensitivity to vibrations, so they're just mounted more or less the normal way. All 4 tubes, they are a 18042. So those are pentodes, and for 18 volts filament. So they're quite special. I can't remember I had an instrument with these before, but I can show you. They're really beautiful tubes. From here they just look like a normal pentode and all that, but definitely a super nice tube. There are a few funny things about this unit. I should probably show you here what's going on. That will be 2 half-wave rectifiers but you're gonna be a little bit surprised. Look at the output here, plus minus and plus minus, but plus and plus go to the same point, and the two sine wave inputs, and the other one is in here, they're not used. I don't know if I can show this, but you just have to believe me, really. So yes, here we can see no wires at all on the two inputs, and that is because they want them to be used at a much higher voltage. So that is why this point is not used. So they put in AC on the negative, and on the negative, the two ends of the transformer, and then they create the positive voltage here. And then it, of course, goes to the standard high voltage parts and all that. Let's look a little bit on the schematic. Let's start in the bottom right, where we got the mains transformer. And then on the secondary side of the transformer, we see the 1, 2, 3, 4 filaments of all the 4 pentodes. They're just heated up by one winding on the transformer. So that's 18 volts of filament. There's some trimmers here on the center points to the left of filament 1. And as you see here, we got some voltage dividers and set points so that the center point of the filaments can be AC neutral. So this is a good way to zero out hum. A very smart way. Let's look at the high voltage rectifier to the right of S2 switch. Those two super big rectifier diodes I showed in the previous clip, they go of course to a capacitor, a ground capacitor center point of the high voltage winding. But the fun thing is that S2 is the band switch, the frequency ranges switch. And as you see here on that section of that switch, the current, the center current of the high voltage go through 2 coils of 2 relays. And that's a little bit interesting. So this is a way to energize 2 different relays depending on the frequency range. But the fun thing is that the inductance and resistance of the coils, they are also a filter, the filter inductor for the high voltage. Isn't that just a little bit amazing? And then high voltage goes via some resistors to the STV 100-25 set. That is a very interesting 100 volt reference neon regulator. But it's a 3-terminal type. So I really think we should probably talk a little bit about this in a greater detail. So here's the data sheet of that STV 100 voltage regulator. It is a 100 volt regulator, and the current is between 5 and 25 milliamps. But the interesting thing, if we scroll down in the data sheet to the pinout, is this extra electrode. And that electrode is a pre-igniter where you pre-activate the neon gas inside the tube so that it will be activated at the 100 volt main regulation point. Because if you do not have this electrode, a normal voltage regulator tube, they go up to quite a high over voltage before they are activated, and then the voltage drops to the regulated voltage. And this particular regulator tube doesn't have this problem because of that third electrode. And if we look at the schematic again here, we see that the center electrode of STV 100 goes up to the positive high voltage, and this way it is activated. the main regulated voltage of the STV100 goes to the first 18042 pentode, and I believe this pentode here is the oscillator, and of course it's connected to all the different gangs of that S2 switch, and that's of course all the different frequency ranges. So this is the local oscillator, and it is fed up to the transformer they call U5 via U3. So this is the injection system where it is mixed with the incoming signal from the first pentode in the upper left where we have input, and then it is amplified on the next tube, and where we have this potentiometer called more amplification, and this is where you can crank up some extra gain in that tube. And then you have a filter section where you can change between a narrow band or a wide band. It doesn't really here say how wide or how narrow it is. And then there is a final amplifier that drives the headphones or the instrumentation output, or if they are not activated, it will drive the instrument so that you can measure the input level on the instrument. So now we'll try and do the first power up. What I want to do is just crank it on and then slowly turn up mains voltage and see what happens. I am looking for light in the voltage regulator tube. As you can see here, it is nice and shiny. It will get very bright. And that is 220 volts. And I do hear some relays. Let's turn off the light and let's see how well all the tubes are lit. That is beautiful. Yes. Oh, this one is bright. Are you crazy? It is bright. I did not expect it to be that bright, but wow, is it beautiful. That is some voltage regulator tube. I gotta give them that. But so far, so good. This is 35 watts and I don't smell anything bad. So now I'll try and see if the voltages are okay, and then I will give it some signals. I think you're gonna be a little bit impressed about this, what's going on here. Look at that. So I believe we got 100 millivolts, right? So the 10 here is of course 100 millivolts, wouldn't you say? And I am in 300 to 1000 kilohertz of input range, and that will be that band here, right? I don't know if it is super visible, but can you see it's about 700 kilohertz? It's drifting a little bit, but let's look a little bit on my generator setup here. 700 kilohertz and 100 millivolts. And the fun thing is I am in millivolt peak, but probably that is what it's detecting. Otherwise, I don't know. Let's try and fine tune. You see? I can crank it up a little bit here, depending on where I am. It is super difficult to hit it the right frequency by hand or by this dial here, and I am even in the broadband mode. If I am in small band or the narrow band, then it is almost impossible. So the filters they have in the IF here, they are really impressive. And yes, so this thing can definitely measure incoming frequency and amplitude, and it kind of still works. And here we go. This is the output connected to an oscilloscope. A little bit annoying thing is that when you connect the output, you disconnect the internal instruments, so you don't know where you are. Then that means you need to look at whatever it is you have connected. But let me show you this. See? You get IF out as well. So you also get about a 930 kilohertz IF output, the oscillator output here. So that is just how it is. But as you see here, this is my AM modulation. And if there is nothing, then there's of course a little bit of spill through. Probably going to be a ton of, let's see if I can get it. So this is, see, it's just impossible to hit like that, right? I should probably just give it a lot more input drive. See, then it's possible. But, oh yeah, and here we go. But anyway, this funny old thing really works. I don't know. Now I just need to figure out where can I use this? What can we use it for? We need to figure out something, right?